everyone. Thanks for watching Johnson Knoll, Senior Product Marketing Manager of Ververica, as he presents From Hours to Seconds, How Peru's largest bank achieves 90% savings through mainframe offloading of real-time data. This session was originally presented at Flink Forward Asia 2025 in Singapore. Johnson, take it away.
So this session is really focused in on sharing how one of our customers, Peru's largest bank, achieved substantial benefits from using Ververica's unified streaming data platform to massively accelerate the processing of their greatest asset, which is their data. And by doing so, what they've been able to do is continue to position themselves for continuing to lead the way with banking innovation and operational excellence and efficiencies. And I'm essentially just going to share their story. But before we get there, we're going to have a quick concept of a mainframe. And I can certainly speak about myself, but I would imagine that most people on this call probably have never seen one, never used one, and may well not know the history behind it. And so, I mean, the concept of a mainframe, I mean, it's been around for many years. And actually, there's Charles Babbage, the chap, the picture in the middle. So he designed something called Babbage's analytical engine, and it was designed in the 19th century. And it's got key features found in modern computers, right, including mainframes. And they have things like separation of processing and logic. So Babbage envisaged this mill for calculations, then some sort of storage for data storage. So essentially mirroring the CPU and the memory in mainframes. And so program input was inputted via the punch cards, and that's the picture on the top left. And that method is still being adopted, not still being adopted, but it had been used in certainly in modern times in the late 80s when I first kind of started out in technology. The lady on the right is Ada Lovelace, and she worked with Charles Babbage. And I wanted to put this picture out there because, you know, I'm a big champion for women in tech, and Ada Lovelace is officially the world's first computer programmer. She worked with Charles Babbage to put the programming together for his analytical engine. And so over time, in the 1950s, so IBM pioneered the technology of mainframes, and then around 1975, you had the likes of Amdahl and Fujitsu bringing in their offerings as well. And so mainframes were historically used for scientific computing, large-scale data processing, early business applications, et cetera, et cetera. This diagram at the bottom left is a screen, and it's close to my heart because when I first got into software, I was working for a global bank, and they had a mainframe, and this was the screen that invited me every morning. This ISPF TSO interactive terminal. So this is how I worked with the mainframe. The diagram on the right is so IBM are building new mainframe solutions which are AI ready, and of course, you know, so the similarity between punch cards and modern tables. So punch cards used to use holes to represent data, and of course modern tables use text and numbers, and so, you know, that's how it all started out. So my first job in software, as I mentioned, was working on mainframes, and this scene from a movie is very close to my heart.
We have sort of a problem here. Yeah, you apparently didn't put one of the new cover sheets on your TPS reports.
Oh, yeah. I'm sorry about that. I forgot.
Yeah. You see, we're putting the cover sheets on all TPS reports now before they go out. Did you see the memo about this?
Yeah. Yeah, I have the memo right here. I just forgot. But it's not shipping out till tomorrow, so there's no problem.
Yeah. If you could just go ahead and make sure you do that from now on, that would be great. And I'll go ahead and make sure you get another copy of that memo. Okay?
Yeah.
So that was me every Friday. Every Friday, my boss would come along and find something wrong with my TPS report, which I used to write in a programming language called CList, which is called command list. So anyway, some interesting things about mainframes. I mean, they're great for scheduling huge jobs and massively parallel I/O, which is why a lot of these organizations run them, which is why they've been around from the 70s and they still do what they do now, right? 70% of the world's data is still being run on mainframes, be it IBM's, Amdahl's, Fujitsu's, and several others. 90% of the world's credit card transactions are processed on mainframes. They're used by the top 10 insurers worldwide. And of course, you can modernize mainframe architectures without having to rip and replace them. And this is an emerging trend. And of course, through infrastructure modernization, you can coexist your mainframe and offload the most valuable and expensive data to enable modern customer-first applications that are future-proofed and ready to be powered by AI technologies. And you can drastically reduce operational costs, you can massively accelerate data processing, and you can transform mainframe data to run modern AI-ready applications. And that's exactly what Peru's leading bank did. Through offloading their most important data, they ran their jobs in 60% of the previous time, so almost twice as fast, right? A 40% saving in anything is pretty good. They achieved a massive 90% reduction in MIPS. So, I mean, this can't be underestimated. This is substantial. MIPS, by the way, it stands for millions of instructions per second. This is about processor speed, time, and subsequent costs. So they've offloaded a chunk of their most expensive asset. And so they were able to deploy Ververica's platform into their existing environment and run their most intensive process in less than 3 weeks. That's from concept to deployment in 3 weeks. So this really tells you about the ability to seamlessly integrate Ververica into mainframes and other infrastructures, right? And of course, they've achieved $1 million a year saved in processing costs, and so that's substantial. So they are the largest bank. They're known for providing comprehensive financial services. They hold approximately 40 billion in total assets, and a significant market share. So, and they're recognized as an innovative and forward-thinking market leader in Peru's financial sector. And being a leading bank, they want to stay ahead of the rest. They aim to be more than just a bank. They want to be a catalyst for change in Peru. They want to leverage technology. They want to promote financial inclusion. They want to foster a culture of sustainability and innovation. And they recognize that modernization will get them closer to where they want to be in the banking industry. They know that they can't innovate with their core components of their existing infrastructure. So their dependency on the mainframe is so great, and they need to find a technology stack that future-proofs their business moving forward. And of course, they've already got existing problems. So this isn't not just about innovation and future-proofing your architecture. They've got existing issues. And chiefly amongst them is the latency with their overnight batch process. So this is a process that would calculate interest rates, detect fraud activity, maintain account statuses, you know, like balances and things like that. So if there were sanctions on accounts and things like that. And so because they had latency, that impact was severe. So they had delayed interest calculations, delayed generation of reports and account statements, late updated account balances, and of course, something that's really quite serious, which is after the event fraud detection. So their overnight batch would run, and then the following day they'd find out that there may have been a fraudulent activity after the event. And this is because they have this batch job. It takes about 8 hours to run, and it's got around 30 daisy-chained jobs or steps, and it's brittle, right? All or nothing. One job fails, sometimes all of it would fail. And this is a COBOL application. So it was written a long time ago, and it suffers from instability and sluggish performance overall, and it's very, very difficult to modernize. So impact to the business, the risk exposure is substantial, because without an up-to-date position on their liquidity, you know, they're going to be doing less business with less confidence. They're going to be missing out on in-the-moment opportunities. So they're either going to be paying more interest on money that they don't use, that they thought that they might use, or they're trying to spend money that they don't have. And of course, if a financial institution's capital, especially in its overnight accounts, fall below a predefined regulatory threshold, then what happens is it can trigger a regulatory alert, right? Potentially leading to penalties. And this is a crucial component of maintaining sufficient liquidity and solvency. It's a common regulatory requirement to prevent institutions from being vulnerable to financial instability. The other issue was cost. So it's the cost of running their core business on a legacy mainframe. And MIPS are expensive compared to other computing platforms. You think about the initial and ongoing investment, the hardware, the licensing, for example. And so their cost model is based on millions of instructions per second. The more instructions your application or workload requires, the higher the cost will be. And of course, they had this credit-based pricing model. So they had to pay up front to get MIPS. And they found this very, very frustrating. And of course, they're spending huge amounts of dollars. And the problem that they have is the ability to predict usage. And that usage is based on historical data, but it's hard to forecast, predict, calculate, and ultimately it's inaccurate. So if you're performing things like chargeback, which a lot of these mainframe systems do, it's very, very difficult to hypothetically say, well, how much is my team using? It's a big challenge. The other thing is the lack of available in-house talent, right, to manage this. You would normally have systems programmers, excuse me. You'd normally have systems programmers working on, the mainframe platform, ensuring it was configured correctly, set up to work with other components. And you not only do you have COBOL, but you've got VSAM, you've got IMS, you've got DB2. And of course, VSAM is a file system that's been around for a long time, and IMS is this hierarchical database. You need people to manage those. You need DBAs. And of course, IMS, VSAM, DB2 on the mainframe, they've been around for ages. They're still there. They're still storing data. They're still holding files. And so, older coding practices, they don't support agile development, and a lot of the talent, quite frankly, is retiring. The picture on the right is basically trying to raise a point that COBOL programmers are as rare as hen's teeth. And banks can't go down. Several banks have had intermittent problems with their technology, leaving customers unable to access bank accounts. Bank of America, Commerce Bank, ANZ Bank, Royal Bank of Scotland, NatWest, they've all suffered similar issues. And these system failures will ultimately undermine confidence in traditional banking and encourage more competition for some of these nimbler internet-based banking solutions. And of course, for many reasons, a new mainframe was not a viable option. And so they knew that to stay ahead, they needed modern architectures designed to cope with this fundamental shift in the behavior in the market, more customer-centric, real-time experience that retains customers, that generates revenue, offers new opportunities. And of course, a lot of the modern architectures that they were looking at, they felt didn't interact well with older legacy back office systems. So ideally, a streaming solution is what they were looking for. They wanted the best performance. And performance isn't just about speed. It encompasses other aspects as well, such as consistency, high availability, and all the rest of it. So they needed to firm up their daisy chain process. They needed to be sure that the modern application supported enterprise-grade job scheduling. The solution needed to have the highest levels of security, and managed services is something that they were attracted to. So what they did was they embarked on a proof of value. So they evaluated vendors. Oh, and by the way, I've put these names in here. I'll probably take them out if that causes a problem. They identified the highest consumption job, and this job was running 4 million events a second, and they wanted to just build this modern solution. And that involved converting COBOL code to Java, preserving the functionality, exporting the data from the mainframe to VSAM files in batches, and then using JDBC to communicate with those VSAM files, run Flink SQL so that we could ingest those as a data pipeline. And they wanted to run Ververica Flink as a managed service. So this was guaranteeing a high performance, elastic scale, security, and all the other good stuff. And it's important to note that actually, as part of their architecture, they could have actually included things like data enrichment, That would have improved decision making, enhanced customer insights, streamline operations, provide better regulatory compliance, and other things that they will find beneficial moving forward. So this is a high-level picture of the architecture. So they're processing these vSAM files. The mainframe deposits these vSAM files, and then these files hold information like office information, account, branch, agency information. And they've chosen within their organization to do the heavy lifting of converting from COBOL to Java and converting the data formats from EBCDIC, which is typically a mainframe data format, to ASCII, and also converting the data types from things like packed decimals and binary formats. And so they're exporting the files, they're moving those to Azure Blob Storage, and so they're using JDBC to communicate with, to pull that data across. Now, this use case is mostly a periodic job. So they're scheduling, so they're running these as batch or micro batch, and I would anticipate that moving into the future, they'll want to convert this to some sort of real-time experience in the future, perhaps using change data capture. And actually, in fact, another customer of ours has used Flink change data capture to pull data from a DB2 database running on Oracle. So they can act on their data in real time. As that data is being written to Oracle, change data capture is pulling off those records, and then it's replaying that through Flink, so that they can get the real time benefits. They could again, look at things like data enrichment or feature engineering and things like that. And this slide looks complicated. It's deliberate, and I've kept it here to raise an important point. If you look at this slide, you've got the mainframe processes, processing payment transactions. You've got data being offloaded to batches of vSAM. You've got Tempura IO being used for durable execution. I mean, they could have used Flink's adaptive batch scheduler as well. You've got Single Store, which is a database platform. You've got lots of different things going on, and this is a physical architecture. And the important point I wanted to raise here is that regardless of the complexity of your technology stack, we can seamlessly integrate Ververica into this platform and deliver real-time data value. So any environment, whether you've got third-party storage systems, mainframe middleware, the impact to their environment is effectively zero, because what we're doing is we've got this layer of abstraction. They're going to be, here we'll give you an example. We're calling an agent here, and so that agent then runs. So that data, this job here is the job, this 4 million transactions a second. It's being called, and then we're running that in Flink to accelerate that data processing, to reduce the IOPS and the MIPS costs. And of course, what we're then doing is we're writing that back into the mainframe system. And of course, we don't have to do that. I mean, or they don't have to do that, but they're doing that at the moment. And so why deploy Ververica rather than anyone else? I mean, we provide a highly scalable and reliable, a single unified streaming data platform. So less components, faster time to market, knowing or very limited integration and glue code overheads, that greater simplicity of the infrastructure. It just means that you can go to market quicker, less testing, faster ROI. We've got sophisticated monitoring and alerting tools. And this actually came from the customer, that our solution enabled the engineers to focus further on innovation rather than building integration or glue code. And that's a big factor when you can focus your time on building the right application rather than compromising on the quality of the application because you've got to build non-functional requirements. I mean, that's not, that's problematic. And so and because of that, and this is an important factor, 3 weeks to go to market with this solution. We've seen these numbers already, 60% of the previous time, so almost twice as fast. 90% reduction in MIPS. I mean, MIPS are expensive at the best of times, but if you can reduce something by 90%, then that's worth talking about. They're running Ververica Flink in using their most intensive process in less than 3 weeks. So this tells you about the seamless nature. And they're saving $1 million a year in processing cost for this one process. So just imagine what they can do when they start looking at some of the other business processes as well. This is an architectural reference diagram of our single unified streaming data platform. It's the same architecture for any use case, regardless of industry or complexity. I mean, this is the same architecture for dynamic pricing, real-time inventory management, personalized recommendations, smart homes, smart cities. I mean, I know Singapore is a leader in this industry, real-time logistics and shipping. And so what this doesn't show the entirety of is the non-functional capabilities that we've got: elastic scale, tiered storage, data lineage, and all the other things that turn a standard application into an enterprise grade solution without onerous plumbing and integration code. You can have all of that out of the box. And of course, we power AI workloads. Here, you can just imagine some of the benefits that they could get from anomaly detection using things like agentic AI, all of these independent AI agents going off and doing things and making decisions without human intervention. And this is just there are similarities between the mainframe environment and the Flink environment. I mean, both of them support batch, micro batch, and a level of stream processing across both of them. Mainframe JCL, temporal IO. Flink is very, very similar. The way in which it schedules the jobs are very similar to JCL. Temporal IO is being used for enterprise grade scheduling, but they could have also used our solution as well for that granular scheduling and control as well. And so in the future, I mean, the bank stated that they would like to consider the impact of AI. So real-time fraud detection is probably the most valuable change that they can make in the short term. So being able to respond to fraudulent activity as it unfolds will yield substantial financial benefits as well. And moving forward, not having to write back to the the mainframe environment will keep operational costs down as well. Moving forward, so if you want to find out more, you can click on the QR code and that will give you more information about the unified streaming data platform. And let's not forget about Flink Forward Barcelona.